Okay guys, so here we go. This week we're basically expanding upon everything we've been doing, so from translations, reflections, and rotations, and we're really looking at the core concepts and what makes them special. And the one thing that's been consistent throughout the whole time is we've been talking about their size, the shape, and orientation. So let's really take a look at what that means for each one. Okay, so we started with translations. All translation was a shift on the coordinate grid from one set of figures to the other. We renamed the second set prime figures, if you remember right. Well, when we had the translation, our size was the same. Our orientation, which is the direction that it's facing, was the same, as well as size, shape, and our shape was still a triangle, so it was the same. And that was the true with every single translation that we did. The size, the same, the size, the shape, and the orientation was going to stay the same regardless. Okay. When we switched to reflections, everything was the same because we were reflecting over a plane, but everything was the same except for same size, same shape, yet our orientations were different. So if I drew an arrow from the base of my triangle through the middle point, see how they're pointing in different directions? That means the orientation was different. And that's what makes a reflection different than a translation. Okay? With our rotations, we had the exact same scenario as we did with the reflection. We had the same size. We have the same shape. But as you can see, after our rotation, it's facing a different direction. It was facing upward here. Here it's facing to the right. So our orientations was what was different. Okay? So that was the main difference. So translations was same size, same shape, same orientation. Reflections was same size, same shape, but different orientations. And translation or in rotations were same size, same shape, but different orientations. So the real thing is, why is that important? Well, it's important because it allows us to see what's happening and how these shapes relate to one another. So let's just take a look. Here we have triangle ABC. Okay, but in geometry as well as in 8th grade math, we have to identify stuff. So here we would say that this line segment is line segment AB, and that's what it looks like because that's letting me know that this line here is my line AB of that triangle. This line would be BC, and this line would be AC. The line over the top is lets us know we're talking about a line segment. Same with, if we looked at our prime figure here, this would be line A prime, C prime would be right here. Okay? What's cool about that is now we can have a context that we can talk about where these sizes of the line segments, how they relate. And what we find out is, since they're the same size, the same shape, and the same or same or different orientations, depending on what transformation we're dealing with, we can predict the lengths of these line segments, and that's what we're really going to be looking at. Here, so if we have line segment here, first thing we always do is list out our line segments. Line segment JK and line segment LK. So now we're reflecting this, okay, and after the reflection we can predict what these side lengths are. So L prime K prime is going to be 9 as well because it's the same line as this guy here. JL, J prime L prime is going to be 4 because it's the same as that line segment there. And line JK here is going to be 6 because it's the same J prime K prime as this line segment. Okay? And that's important, especially as we're deciphering and we're figuring out our next unit, which is called dilations, where we're talking about magnitude and size. Same thing with rotation. So as I'm rotating this, if I've identified And here, this is a good one because these figures aren't labeled, so this will become triangle ABC with line segment AB equal to 5, line segment BC equal to 5, and line segment AC equal to 8. Well, if that's the case, I can identify this is going to be my A prime, B prime, C prime. So then this would be also 8, this would also be 5, and this would also be 5. See how they relate? These little side lengths now also relate to the prime figures, and we can decipher what they are. Lastly, I wanted to talk about angles, and what's really cool here is we find out what's called our angle sum theorem. So we're going to go angle sum theorem. Underline that because that's a really key point and allows us to do lots of cool stuff, and that's really the gist of what we're working on this week. But here, as you can see, if I have triangle ABC here, and this angle is 115, and all I did was translate it up here, well, here we go. We know this is also going to be 115. And if I take a look at this angle, angle C in this case, well, angle C is also the same as angle C prime, so therefore, this must measure 30 degrees. And this guy is 35 degrees. Okay? Well, what's really cool is if you really start looking at it, and it's the same for every single triangle that you deal with, if I take 115 plus 30, I get 145. And if I take 145 and add 35 to that, I get 180. And that's what the angle sum theorem says. It says all angles of a triangle will add up to 180 degrees. Okay? So if I'm looking at it from this perspective here, you can always write out an equation which would say for this one it'd be angle A plus angle B plus angle C equals 180. And that's going to be the gist of our lesson today, how this angle sum theorem works and how do we write equations so we can solve for the angle sum theorem every time. Thank you for your time. Good luck with the rest of your lesson.